we continue this sequence in a way, because the next talk is about software-defined car. So you don't need a real car, it's okay if you car by software. That's what I learned from the title. The speaker is Professor Weyrich from the University of Stuttgart, but not, as I understand, from the Computer Science Institute, but from the Industrial Automation and Software Engineering.
Yeah, thank you very much. So very welcome, everybody. And yes, indeed. So I'm going to talk about the software-defined car. And actually, first I will discuss a little bit what that is actually means and where this term comes from. And then I'm going to take you on a little journey because we have a very big project at University of Stuttgart jointly with the major German industry players, and I will report a little bit about that project and give you also some overview of what type of research we do. So it's not really going in too much depth, I'm afraid, that would take too long, but it's more like an overview contribution today. So, software-defined car, pathway and challenges towards IT for future automotive application certainly raises the car, as it was mentioned. What is this software-defined car actually? Because usually it got like 4 wheels and lots of horsepowers, and that is like important, and you have a certain sound of it. But the terminology is about vehicles with new features which can be implemented mainly by software. So just think of autonomous functions or maybe some sort of comfort functions in your car, entertainment and these type of things. And well, people believe that there is a gradual transformation in automobile from like what we have today, the vehicle of today, which is almost innovative, many people say. Of course, there is discussion about electric drive and batteries, but you see that light at the end of the tunnel, and in future it might be about intelligent, expandable mobile electronics that can be continuously upgraded to give you full comfort. So that is the idea of it. You do not need to believe it, but that's how it is defined. And certainly, interestingly, this became very popular in 2018 because this big industry, the Volkswagen, the former Volkswagen CEO Herbert Diess said that Volkswagen will become a software-driven car company. He said that in 2019, by the way.
I don't understand it. So is the company software-driven or is the car software?
Would become a software-driven car company, sorry. So the company is driven by software-defined cars, which means the whole company being very good in building engines and these type of things would in future need far more software competencies instead of these mechanical ideas, which is a big change. And actually what happens, you see on the next slide, this is Oliver Blume. He succeeded this guy a little later because this transformation failed. And he was removed because it was a full-fledged disaster. Many of the Volkswagen cars were delayed because of software issues. And so they removed that visionary guy. It was a nice visionary guy actually, but they removed him and took this guy, and he's more like the restructuring guy, and now fires everybody in the IT sector and so forth, right? But this tells you a little bit about what type of challenge there is, because that is not so easy, and Volkswagen is some sort of six, and Germany is also not doing too well, you know. So, and certainly the same holds for Mercedes, I believe, or BMW. But there's more to it. See, for instance, the NVIDIA boss, sorry for having this in German, said Mercedes will become the most prestigious luxury brand in the future. And just gives that a second of thinking, right? So a computer guy doing this NVIDIA cool stuff tells one of our premium brands, and Mercedes is like top-notch in Germany, you will be like the luxury brand of the future, which means you are not doing electronics.
Is it recently? The quote is from recently?
What?
A quote is from recently?
Yes, he just said that recently. Yes, indeed. So I'm not sure. Let me tell you. He said that 27th of March last year. So not so recent, but at least. And you see more highlights here, like which is a big fear in Germany. BMW will use iDrive with Android and stuff like this. Same time. Many other discussions, just to give you more background on where we are. Many people talked about autonomous vehicles and said this is the future. And whenever you go to San Francisco or so, you will drive the Cruise and the Waynos, and you will see all these little gadgets. But then don't think that this will come like tomorrow, because, for instance, this is the news just recently. Mobileye was supposed to build for some German cities these autonomous vehicles, and they took the contract and then they rejected it after some time, and you get the news they will not have any admission for German roads in the close future. And I actually had the chance to talk to the CTO of Mobileye, which is a very big and important player in that field. And he told me that how people put it in words. He said, we only say that things are ready once they are ready, which means they fail to deliver. So, but anyway, this is where we are just from the press, and just to give you an idea of what software-defined car means today. So many things are moving, but it's obviously not going too smooth. So, and what I will talk about is these 3 points. So a little idea about the state of the art in this automotive field. I tell you a little bit about the research in software-defined vehicles in our lead project, and I'll give you 3 example research projects of my PhD students.
That situation you showed for Germany is the same for US and other countries. They do not have full autonomic drive. Even Elon Musk is reporting on this, right?
Yes. Of course not, yeah. So it's a battle about, you know, the market is very big and important, and so people say a lot of things which are more driven by some considerations of euros and dollars and not so much by technology. This is what you also need to keep in mind. But anyway, let me tell you a little bit about the automotive state of the art, which is like what we have in the cars of today. Today you have a automotive world where you have about 100 plus electronic control units in each vehicle. It depends a little bit on the brand, sometimes a little more or a little less. And you have 15 different communication networks or derivatives of those networks in your car. And I once heard the most expensive car in the vehicle electronics is actually the wiring, because you have all these little wires which you need to connect and different cables here and there. So, and that is the situation where we are in, right? And we also use a system which is called AutoSAR. It was invented 2003, so 20 years old, which is some sort of the operating system interconnecting all those ECUs, right? So it is great, but a little old, certainly, if you look into IT. And you got, like 3 years ago, newspaper reports like this one, that Tesla has an advanced architecture using some sort of big computers and their own chips and smarter cabling. And well, I believe this gave a lot of change to the industries, that they realized, well, actually we should also go in this direction and get over these many ECUs and all these cablings. But still today, this is somehow the situation. So, but now, let me tell you more about the situation. Same time, you go out and you go to automotive fairs in a second, and an automotive fair like this one in Tel Aviv recently, called the EcoMotion, and they only talk about IT. They had about 100 IT companies, and each company, mainly startups, young people here, startups, right, in this new field, and they talked about different aspects of smart mobility. So 100 ideas with venture capital going into that area. And why I'm talking about this, I get a lot of inspiration, because you can see where people actually want to invest and where they give their money to. And this certainly means that this is obviously a good idea for the future, and some other topics may not be. Right? But we also had a very interesting discussion, and that's important for us researchers too, here in Symposium, where one guy, the former governor of Florida, said only social sheep who are managing to combine the technological developments with a business model. Which means, vice versa, for us in research, we should also look a little bit into the market of what is actually required and in which sequence, right? So there are many topics out, and you can do great research in that field. You will see that I present you a huge portfolio of research ideas later on, and but certainly the question is on how to top it over the course of time in the next close future. So what's the question?
Do all suppliers and manufacturers comply to this open system architecture?
AutoSAR is not an open source thing. They do not comply all, no, but there is a huge baseline because Volkswagen, BMW, and Mercedes and some others do comply, and you don't get any business if you don't. And it is, by the way, a stack which is delivered by 2 commercial companies, and you need to buy it. It's pretty expensive. It's far away from open source, and for legal reasons, by the way. So there is a lot of legal impact in it. So you can't really use open source too easily. So, but that is the new world, what is coming up, and I don't need to tell you. So we will have like the cloud in future. Actually, many clouds are probably around. We will have the edge and the fog, wherever that exactly is. It's a different question, but it is somewhere here. You have loads of vehicles being like supercomputers on 4 wheels, as people call it, and they are certainly interconnected, but they are also interconnected with their environment, like with the roadside, traffic lights, and so forth. And certainly they will send the information via the edge or the edges into the cloud. And well, then certainly you have some servicing companies, and you have the OEMs and the tiers looking into their vehicles once they are on the road already. So that's a new cool future with lots of data lakes where you can store and see where you go, what you do, and so forth. So that is like the big nice future which we have, which certainly means that a full new ecosystem for data and so will come up. You have like certainly the digital vehicle. I was just talking about maybe AutoSAR after 20 years is not the really best solution for the future with even more electronic comings. But you have also a digital infrastructure like traffic lights, roadsides, and so forth. And you may have loads of digital services which are provided by OEMs and also suppliers, right? So this is something which we need to keep in mind because it will change the world how it is today dramatically. And this is why people actually say, well, that's like software-defined car. It makes it possible to interconnect all these things together. So that is some sort of a vision. And nobody really knows where it goes, but as I was saying, in Tel Aviv, 100 companies having a minimum of 100 ideas, and I was astonished what type of venture capital they could collect to actually implement this, which is a lot. So, but what does this now mean for us, and how can we actually tackle it? What are research topics, right? So, and they are like, this is a new loop which we probably have when we develop a vehicle. So there is some continuous functional development, which is also called the CI/CD. Validation, verification may become very important. Over-the-air updates are already feasible. You connect with your car, maybe you have a data loop in future. You have operations of that vehicle. You may have a digital twin of this vehicle and all the others, which might be also interconnected, and so forth. So this is like the brave new world. And certainly many questions are in it, like how do you actually manage those data lakes which are created by the multiple digital twins? What about IT security, which becomes important? What are the analytics to actually process those information which you can collect now in the field? Or certainly you have new ways of actually developing and delivering your software, high performance computing, and certainly new operating systems. So this is all in the air these days and makes the whole scene a little nervous. So especially in the German news, we get lots of news because the whole system is about to have a paradigm shift in future to go more into the software, and as like the old mechanical stuff is not so relevant anymore. But for us, at least for me, there are two lead questions, which are very simple actually. So if this all happens, however do we manage the complexity which we are creating with several edges, clouds, road to vehicle, connecting of this and that? This is like super duper complicated considering the amount of cars which we have. And the software doing this is not just an app on your mobile, it is like a couple of apps, and so huge complexity issues. And certainly once we manage this, and this is also like a little difficult question, what are actually the real features which we gain and how much are they worth? I mean, it's a very cool thing to interconnect everything with everything, but what does it mean to us? Like, are we willing to pay for it? And how good is that type of functionality actually? And is it worth the whole effort, right? So the race for new functions and features is also pretty difficult to answer, especially in the context of the complexity which you may create and all what belongs to it. So, well, this is, so to speak, the starting position for a project which started some time back, and some of the participants here at the conference are also part of it. It is the software-defined vehicle. German government actually gave a huge sum to these companies and said, well, you should actually better go and research about what that all means to us on a more concrete level, right? And they gave a pretty big amount. So we at University of Stuttgart, we are part of it, and some colleagues here in the room as well. Mercedes, Rose Sturm had presented recently, but other companies like Bosch, ZF, ETAS, and Vector are some specialized IT companies for automotive, and KIT, neighboring university to Stuttgart and others. So we are pretty much in this. And we focus on, a network of all vehicles and infrastructure, digital twin, and the data loop. So data loop, digital twin, certainly redeployment of software, like new circle of software engineering with updates over the air. This is what that means. And certainly we want to demonstrate those new technologies to make clear of what is actually really happening with it. You know, these visionary type of sketch slides are one thing, but you know, in car and automotive, you need to have demonstrators to prove your stuff. And this project, just I give you a glimpse of what type of use cases we are looking at University of Stuttgart. The project is very big and it has several other use cases as well. But just to give you a little bit of the flavor of what people think of. So there is one person very active in the development of variant-rich software for the software-defined vehicle, which is a big topic, you know. You have like different vehicle brands or manufacturers, they have different brands, each brand has different model. These models evaluate over time, and in the end you have like a variance of your software, which is like super and very, very difficult to manage. Just if you take ordinary software like blinkers and wipers and so forth, you get like for each different model of OEMs, you get a huge variance. How to manage that actually? Especially when you can do over-the-air updates for whole fleets of your vehicles. If you don't like your software, you update it, no problem, and everybody's having the new one. But with the amount of vehicles and differences, that's a big thing. And certainly, how would you orchestrate those components in the vehicle? You know, if you look into automotive, you will see that it is not like Mercedes, doing it all and having the big plant and producing it. It's actually a supply chain of many, many different people who deliver to Mercedes or who deliver to the guy who delivers to Mercedes and so forth. It's like the tier structure, as they call it. And there are many players in it, and they all need to synchronize once it comes about update of these components, which is certainly very difficult because still it's a Mercedes car, let's say, which belongs to you. And do you want to allow like the sub-deliverer of the sub-deliverer to enter your car via some sort of an internet tunnel and change your motor control, for instance? That is very difficult and needs definitely a very elaborated type of software which can cope with the different variants of that software and make sure that you get this piece of software which you want and which works. So, huge topic comes under what we call the redeployment. Next topic is going even further. It's the so-called data loop, right? People in autonomous driving have that because you can collect loads of data from the car, you can collect camera data, LiDAR data, everything, and send it back to the OEM or to whomsoever. And certainly this means you have huge data streams which are going back and forth, and you need to do some update analysis on what actually you do there and how it correlates with this particular car which you are watching, right? And it certainly goes even to topics of federated learning and privacy, because I'm not sure how you feel about it, but if my car, you know, the modern ones even have like the LiDAR and sensors in the cabin itself to see if you fall asleep, what you actually do. So you get lots of great pictures on where you drive, what you do, how you drive, how much you accelerate, what your girlfriend is doing, like, and so, like this Aldous Huxley, you know, and these 1984 people writing these science fiction type of novels 100 years ago, they couldn't imagine what
one reaction during the talks on cars was, I buy a Dacia.
And you buy a Dacia. No electronics or mechanics. Yes. Indeed. So, but you see, on the other hand, it's of course a huge opportunity to improve the vehicle in the field, because for the first time you can actually connect to your customer and see what this guy is actually doing with it, and certainly optimize that vehicle for that customer in a way that the customer likes it even more, right? So that is a good thing also, and you get lots of comfort function. I will come back to that later on. For surprise that you may have, you may see things you shouldn't see and stuff like this. Don't think that this isn't a reality. I was in Tel Aviv at companies that do security, and they have a control room, they mirror the data lake of a big American OEM having loads of cameras and stuff, you know it all. It was mentioned earlier, and they watch it, and they see the camera pictures of everybody. And it's outside the EU, and the EU data laws are not applicable and so forth. So this is already a reality. But anyway, once we have that, there is another big topic, as I was saying, the digital twin, which is of course another huge opportunity for us to collect the data, to actually compare it with models which we have, to really see what the real vehicle is doing in comparison to the models which we have and what that all tells us. So certainly that can be used for environmental detection, or for anomaly detection, which is a very big use case. You can even integrate multiple digital twins between like vehicles of the same brand and see how the one is performing against the other and what is the cause of it. So huge opportunity also for engineers to actually improve the product and provide new type of functionality. And lastly, and this is very important to us in the project, we need to demonstrate it, because just being philosophic is like one thing, but you really need to nail it down. So IT in automotive is pretty complicated, unfortunately, and sometimes things don't work that easy as you may think, right? So, or they may work in a different way because it's such a huge application field. And certainly here we look into the event-based communication of the vehicles. We have a big test bench integration, And certainly we are looking into a multi-agent system that can really coordinate like the vehicles and the infrastructure and all these information flow. So that's what we do in general in the project, at least from my viewpoint. I'm aware there are more angles to it, which I cannot all cover today, just to give you a glimpse. Here are some more topics. So we also have what is called the Innovation Campus Mobility at University of Stuttgart, and just to add here some projects to give you a little more flavor of what we do here: over-the-air communication for sustainable energy management, integrated approaches for software deployment, upgradable vehicles, standardized test procedures, or improvements in product creation and operation due to abnormal situation analysis and stuff like this, right? So German government is heavily funding this to actually come up with new ideas and new solutions, and we can be part of it. By the way, this is our pictures. This is our Arena 2036 in Stuttgart, where we have some good research space where we can work jointly with industry in a public-private partnership. Okay, but now I'd like to give you some more detailed information about what exactly my PhD students would be doing. So this goes a little further, not too deep unfortunately, because of lack of time, but just to give you some more technical background. So we are implementing, under the umbrella of this project, a 5G network vehicle test scene. This is the campus of University of Stuttgart. For those who know it, they know here's Pfaffenwaldring, and this is our ring road. And we are implementing two 5G networks, one public, probably from German Telekom, 5G connected, and one so-called private 5G net, which is part of the arena and will be part of the surrounding, which could be like representative for a company private 5G network. And we are studying how to combine things, how to interconnect the vehicles, and so forth. So this is in the process of purchasing. Why? Because it's of course one thing to think about how you could interconnect a vehicle and really do it with multiple participants via a real network with a real cloud server system, edge system. You have different latency times than you may think, varying bandwidth. So there is lots to the practical application, which we want to study with this installation at the university. Also like remote function provision and stuff like this, you know, vehicles learning from each other. So nice dreams, but certainly the question is how fast is the learning, how fast is the information flow, and so forth. The second demonstrator which we are building up is a advanced cockpit in our lab. And actually, I think Rose mentioned it already. There is this famous Mercedes massage seat which we are going to purchase. But we will certainly also have some dashboard, entertainment, navigation, ambient light, in-cabin sensors and stuff like this, which we aim to connect to work on new type of functionality, which you can have when you have these digital twin type of technology, interconnect all the information and the digital twins. So this is what we are presently actually building, including the seats. So purchase order is out, I believe. So and then we can actually test it and see how that works. So there are things like autonomous comfort and stuff like this, which are new functionalities my PhD students are working on. The status of this testbed is we've got almost all budget ready, and we hope to get it installed this year. The 5G potentially takes a little longer, but the cockpit should be ready by autumn, and then we can do real experiments and try things out, and not only look like from a theoretic angle how it would be if we could do it. So I now promise descriptions of like 3 research projects which we are doing. So one is called like cooperative perception of connected vehicle. And the idea is very simple. You have a swarm of vehicles. You've got like 5G network. You have a, let's say, cooperative map where you map all the information of those vehicles, what they do, and you use this information to to actually learn from what other vehicles would do. Like, how can vehicles, swarms, perceive their environment in a certain way? So like, you have warning functionality if there's a problem, or one guy at university is working on a solution. You may have some holes in the road, and the traffic in front of you, the bumpers go like bam bam, and certainly you could learn from that vehicle that you should stiffen your bumpers, because soon there's going to be a hole, and then you don't have this effect. You know, so many comfort functions are being tested using the 5G, and like the idea of having a swarm, and also process certain information in the cloud. So many questions are actually in this, on how you can process the information, how far it is, how fast it is, and what latency means, and so forth. So the idea is that vehicles can maneuver in dynamic situations and have a better perception of their environment, using the 5G technology and certainly some sort of a intelligent cooperative perception. But this can certainly not be done in the cloud, because once you would roll it out to whole of Europe, you would have 100 million vehicles just to connect it to one cloud, and then boom, it wouldn't work, right? So you need to think about like an edge architecture and stuff like this. And there are many open questions on how this exactly should work, and what are actually the contingencies if you want to do this. And this is what this guy is doing with the 5G network, really checking it out and how it works. The personal autonomous comfort is something I like personally a lot. That is like, I believe some of the Mercedes cars have it already. In the S-Class, you get these type of things, but our idea is, like if you go to work in the morning, and we have a very big tunnel where I live around Stuttgart, and once you enter this tunnel, I usually need to tune my radio a little bit because the volume is not okay. And I do that every morning, and every other car probably does it as well. This is ideal for swarm intelligence to actually tell you, you know what, all cars like increase volume, don't you like to do that as well, right? And you just point to your radio and the volume goes up. So this is some sort of ideas people have. Or another idea is you want to enter a parking garage, and you have to wind down your window and get pressed, you know, but certainly everybody knows at this position, you know, window is pulled down, and you should just point to your window, and then it goes down. This is what the autonomous comfort actually means, and what we try to figure with our installation, to see like how comfortable that really is. I mean, it sounds great, but how much would you pay for it? I'm not sure. So, your Dutcher. Hopeless case. Anyway, but this goes into the question: how can I actually utilize like real swarm type of data using digital twin and all la-di-da type of thing to deliver a functionality which gives you a feature in your car cockpit which you like, right? And that is not an easy question to answer, and it needs certainly lots of experiments and demonstration to actually find out how that goes. Yeah, certainly it has also to do a lot with privacy and stuff like this, because you also need to exchange a lot of information, certainly to be able to evaluate it accordingly. And we found that there is not so much of research done in that field, which really comes down to these type of real-world applications. Or a third one, which Rose Sturm and myself we are sharing. He is a person also working inside Mercedes, but like being supervised in our graduate school at University of Stuttgart. Is this particular case? It's a distributed integration of ECUs, as it is called. And I'd like to explain that a little more to you. See, like Mercedes is actually a big manager of all their suppliers, and they have their sub-suppliers, as I was saying earlier. But now you want to deliver a new S-Class, and you have a very complicated development pattern, because all these people, they do that today, need to deliver their software, and there is a certain place in Stuttgart, Sindelfingen, where they all like have their plug activities and try out their software. That is the world today, right? But in future, once you have over-the-air updates and everything is like virtual, and you know, things become far more flexible, and you can actually update your software like every second day using DevOps and so forth, theoretically. But before you deliver, you need to certainly integrate it and test it in a proper way. And the idea here is to interconnect those suppliers. They usually work worldwide by today, having lots of activities also in India, China, and on other places. And then how to actually bring that together virtually. That is like somehow a simple question, but practically for OEM like Mercedes, a super big issue and very cost intensive. And one of the PhD students is analyzing on these remote physical testing of geographically distributed control systems, ECUs, right? Using simulation technology, but in a way that it can be utilized by those partner companies, which is a big thing. And this is why he's also inside Mercedes, to actually understand more about the relationships those companies have. We couldn't do that at university as such. And problems are certainly obvious. You have like long latencies and stuff. It's not like just integrated. Latency will come and you need to somehow find ways on how to do that. So that was it already. So my conclusion, there's a lot to do, and many of those questions are pretty much unanswered. And once you start thinking of it, you really realize that this is a new age which is coming up, right? Because lots of things are going to change. However, as I was saying initially, and this is why we are looking so much into like also industry and startups, the big question is like in which sequence is this arriving, right? So and what should we research on first and second? And we did a lot of studies on this, and I believe, at least for my group, these are the topics like data loop. How can we actually have such a cooperative perception? Or in redeployment, how can this so-called CI/CD tool chain, the DevOps, be done in automotive in a way that it actually works? How can the digital twin, which is a beautiful, very popular concept, but how can it really be used, synchronizing with real-time processing and all the different aspects in automotive? And how could we actually demonstrate that to make sure that we really hit the real-world problems people have in the time frame where it is relevant? So thank you very much.
Okay, thanks a lot. Are there some questions, please? Yeah.
I was wondering if you would comment from your perspective, coming out of the technology area, where you see the I was going to ask, where do you see sort of the biggest opportunities for, let's say, German car manufacturers, and maybe also the largest sort of areas of danger vis-a-vis Tesla, and also vis-a-vis the fact that the big IT players, particularly American players. Do you have a kind of view on that?
Yes, I certainly have. If you open a German business magazine these days, every second day we get a title. New operating system is coming from the US and killing the value creation in Germany. And I don't know what, these type of titles. And yes, it is a threat. If we would like twiddle our thumbs and not do anything and just say, hey, we are great in welding and we can paint it more beautiful than everybody else, this wouldn't work, right? So The question is, what is really happening? So, and it's a very complicated world. It is not like Google is moving in and is taking over the car electronics, because this car electronics is by far too complicated. On the other hand, you could see Tesla being pretty smart in somehow delivering something which you can challenge a lot if it is really great or not, but they did it. Right? So the question is now how to progress on this, and there's a huge discussion in Germany how many operating systems you actually need, how you go with these all 20 years old AutoSAR, and so forth. And what I feel is they changed already gradually. Usually they don't like to talk about it, but there's lots of activity, as I know. However, the European idea is a little different from the American. The American is like consequently, they believe like one big player, for instance, Google or Amazon, is like in the middle of it all, and the rest is circling around it. And so, but certainly the European idea goes more into some sort of designing a hardware abstraction layer for the electronics, where you can substitute different electronic elements and also different components for certain functionality. Right? So that is consequently the idea of our OEMs, because this will bring them in a position where you could substitute NVIDIA against some other supplier of chips in the close future. Right? And we will see how the race ends, I don't know, but I hope the best for my country. But it's very, very tricky, and it's a dangerous time for the German OEMs, because if that would really flip, and if you, as you could see, if NVIDIA would win the race, for instance, and be like the central electronic supplier of it all, and just say, hey Mercedes, you are just delivering a great car, this is not what we want, right? And certainly this is the race which is on, and ladies and gentlemen, it's about a lot of money. It is such a huge market, don't forget that. There is everything possible going to happen, right, because of this money.
Some more remarks. So the market is so big that even Dacia from Frank has a space in this market. Okay. Our next topic is the poster session, and it will be executed as usual at Villa Amorosa.
Ella had a question.
I can ask
I'm sorry.
They have
Okay.
more than one discussion. I'm fine. They have a lot of